Welcome back. Today we will be doing a revision on science on the topic matter and their three states. Okay, how it's going to be done is that we are going to do a few questions. We're going to discuss a few questions and how are we going to approach those questions. Okay, now let's take a look at the first question. Now, Jonathan inverted a glass and lowered it into a basin filled with water. He then placed a bent straw under the glass as shown in the diagram below. He began to suck some air out of the glass. Okay, now I already circled a very important point, suck out some air. Now for matter and the three states, some common keywords when you look at the question: air takes up space, water takes up space, air escapes, water escapes, water level rises, water level falls, water level in the basin rises, water level in the glass rises. Okay, these are some of the keywords that should come to your mind when you are trying out this question. Okay, so let's take a look in more detail at this question. Okay, inverted a glass and filled with water, so the whole basin is with water. So inside the glass there is some air. Now what Jonathan is going to do is Jonathan is going to suck out the air. Okay, now when the air is being sucked out, there will be less air in the glass, so water will rush in. Okay, now this is a question that is testing you on the subtopic of air occupies space. Okay, so this is the most important thing here is air occupies space. Okay, so this is the topic that's being tested here. Okay, let's take a look at the question. What would happen to the water level in the glass? Okay, we are looking at the water level in the glass, which is this. Okay, be very careful. There will be questions also asking about water level in the basin. This is water level in the basin. This is water level in the glass. Okay, now as you suck out the air, there will be less air. So when there's less air occupying the inside of the glass, water will rush in to take up its space. So for A, what will happen to the level, water level in the glass? The water level in the glass will increase or will rise. Okay, I repeat. For part A, the water level in the glass will increase. Okay, now for part B, 2 marks, explain your answer in A. Now like I say, the person who said this question is testing on air occupied space. Okay, so the first thing you must write is air occupies space, full stop. As Jonathan sucked out the air, there is less air occupying space in the glass, full stop. Hence, water rush in to take up its space. I repeat, first you must state air occupies space, full stop. As Jonathan sucked out the air, there is less air occupying the space in the glass, full stop. Hence, water rush in to take up its place. Okay, so this is how you are supposed to answer this question. Okay, they are testing on air occupied space. When there is less air occupying the space, something else will rush in to take up its place. Okay, which is the water here. Can? Now take a look. Let's take a look at the next question. Ali wanted to investigate an important property of air. Very important property of air. He set up an experiment as shown in diagrams A and B below. Water flowed into funnel A but did not for funnel B. So this is the setup. What was Ali testing in his experiment? Explain your answer in A. Now first, we don't want to straight away jump into the question. Okay, let's do some basic revision first. Now, property of air. Now, when you think about property of air, a few things must come to your mind. Okay, air has no definite volume. Air has no definite shape. Air can be compressed. Okay, these are the three most important things. Then, you have just now what we discussed, air occupies space. Okay, because air is matter. All matter occupies space. Okay? Then now let's take a look at the question. What was Ali testing in the experiment? Now then we take a look at the setup. We have a funnel. we have a beaker. Now we have this little tube here for the air to escape. Then water come in, the air escape. Okay, so at first there's air occupying the space. Then this tube allows the air to escape and allows the water to come in to take up its place. Okay, now for this setup, there's no tube. So the air is occupying the space. Once you pour the water in, the water will be stuck because the air has nowhere to escape. So air occupies space. Okay, so what was Ali testing in his experiment? Now this is not a very scientific way of asking. Okay, so this question itself, when the setter is trying to set the question, most probably he didn't think through. Because what was Ali testing actually is a very vague question. Okay, a more scientific way of phrasing the question would be, what is the aim of the experiment? Okay, what's the aim of the experiment? Or what was Ali trying to find out from this experiment? Okay, now the answer to this question is, Ali was testing if air occupies space. Because this one, the air can escape, so water comes in and takes up its place. But here, the air occupies the space, no escape for the air, so when the water comes in, cannot take up any more space. The water is not allowed to take up any space at all. So air occupies the space here. Okay, now I'm going to phrase it in answer form. Okay, what was Ali testing in his experiment? Ali was testing if air occupies space. That will be part A. Explain your answer in A. Okay, now the answer for part B is, for setup A, air is allowed to escape through the tube and water can rush in to take up its place. For setup B, air occupies the space in the beaker. Water cannot go in to take up any space because the air has nowhere to escape. Okay, I repeat for part B. Air occupies the space in the beaker. Water cannot rush in to take up any space because air has nowhere to escape to. Okay, that's for this question. Again, it's on air. Let's take a look at question 3. It's question 4. Okay, question 3 I skip. Now, Jenny set up an experiment as shown below. She connected 2 empty glass bottles with a glass tube that contains a drop of ink in the middle. Then we have short glass tube. Okay, then we have a tube here connecting the 2 beakers or glass bottles. We have a funnel here and we have water from a jug pouring in. Then bottle A. Okay, now this setup I will explain a bit first. Okay, now what happened is that there's air occupying the space. So when water is poured in, the air here is going to escape through this tube and pushes the ink drop. And then water will rush in to take up the space here. The air that's escaping through this tube will push the ink towards bottle A. And then here, as the ink drop is being pushed here, the air is also being pushed out here, and the air escapes through here. Okay, I repeat. Now as water is being poured in, the water enters and takes up the space and pushes the air out. The air has to escape through this tube and pushes the ink drop towards bottle A. Okay, as the ink drop is being pushed to bottle A, some of the air here will also be being pushed to bottle A, and the air that was in bottle A will be pushed out from this short glass tube. Okay, this is how the experiment is going to work. So what do you think will happen to the ink drop when a jug of water was poured into bottle B through funnel A? The ink drop will move towards bottle A. Okay, answer for A. The ink drop will move towards bottle A. Explain your answer in A is exactly like what I said just now, but let's put it in more exam-friendly manner. Okay, air occupies the space in bottle B, full stop. As water rushes in to take up the space in bottle B, comma, air is being pushed out of the long glass tube. full stop, it pushes the ink drop towards bottle A. Repeat, air occupies the space in bottle B. As water rushes in to take up the space in bottle B, air is being pushed out through the long glass tube. Full stop. It pushes the ink drop towards bottle A. Okay? Now let's take a look at the next question. Sally wanted to find the volume of a lump of plasticine. She used the setup shown in the diagram below. Okay? We have the measuring cylinder, we have the displacement can with the spout, we have the wooden block, we have the lump of plasticine attached to a string. The steps that Sally needed to follow in order to find the volume of the lump of plasticine are given below. Arrange them in the correct order by writing the numbers 1, 2, 3, 4 in the boxes below. Now this is a very common PSLE type of question where they give you the steps or the procedures, and they ask you to number which one come first and which one is second, which one is third. Okay, so this one is important and it's actually very easy to do. Okay, now let's read the procedure first. Gently lower the lump of plasticine into the displacement can. Place measuring cylinder under the spout. Note the volume collected in the measuring cylinder. Pour water into the displacement can until it starts flowing out of the spout. Okay, now which one must come first? Now you don't lower the plasticine first, so this cannot be first. Place the measuring cylinder under the spout. Okay, it's logical. This might be first. Okay, note the volume collected. This one will also not be first, because only after you lower the lump, then water can be collected. Pour water into the displacement can until it starts flowing out from the spout. This one is also one of the first steps. Now then we have two things to choose. We place the cylinder first, or we pour water first. Now let's say we place the cylinder first, then we pour water in. Water rises, then the water will be flowing out from the spout. Then when the water flows out from the spout, then your measuring cylinder will have some volume recorded already. Then your experiment will not be accurate, because you have an initial volume here when the stone is not even lowered yet. So you cannot put the measuring cylinder under the spout first. So measuring cylinder should be out first. The pour water into the displacement can until it starts flowing out from the spout should be first. So this one should be the first step. Okay, because you take away the measuring cylinder, you pour until the water flow out. That means it's already at the brim here. Okay, then you place the measuring cylinder under the spout. Then your measuring cylinder will start from a 0 reading. There will not be any water inside. So this one should be number 2. Then you put the plasticine in. Then as the plasticine slowly sink to the bottom, the volume of water will increase because it's being displaced by the volume of the plasticine. So the water will flow into the measuring cylinder. Any extra water that is flowing into the measuring cylinder is the water that is being displaced by the plasticine. So this one should be 3. Note the volume of water collected in the measuring cylinder. This should be 4. Okay, so I repeat, 1 should be pour water first. 1. 2 should be place cylinder. 3. Put the plasticine in. 4. Measuring the volume being displaced. Okay, that should be the way. Now many students will want to put the measuring cylinder first. Okay, but that's the wrong answer. So be very careful. Read properly. Take your time. The questions sometimes are tricky, but most of the times they are very straightforward. Just remember your concepts, remember your keywords, and everything should be fine. Okay, have fun. That's all for our revision for matter. Thank you.